because that either one of the force is going to be greater in magnitude. That means that the object will become and basically will come under the influence of the greater magnitude of force, right? So that's why unbalanced forces are there. Okay, balanced force can just change the shape. Suppose that you have a I have a ball, right? Me, just a second, let me just remove. ठीक है, suppose that अभी देखो nothing is there, so I have a very ये a smiley ball जो होती है, this is a smiley ball, so I'm basically exerting same amount of force on the both sides. What do you feel right now? What are you feeling?
The ball is.
What do you observe? Ball is getting compressed because I am
Yes, sir.
exerting the same amount of force on both the side, right? देखो shape change हो रही है ना, elliptical it's going to be like a oval shape instead of
Yes, sir.
complete circle.
Yes, sir.
So that is the case. ठीक है? So it means that whenever you exert the same amount of force on both the sides, that means the force is basically the balanced force. Clear, everyone?
Yes,
Yes,
sir.
sir.
ठीक है? Yeah. So okay, and if so unbalanced force can only change the shape of the object. Clear?
Yes, sir.
Chalo. So yes. Does anybody have any doubt? Please let me know.
Yes, sir.
No, sir.
Sure, okay. So now let's understand the balanced forces definition. Then we will do the unbalanced forces. Okay. So these are the characteristics. Just sorry. So unbalanced forces. Okay. So balanced forces means if all the force acting, it means that if all the force acting, and if you take the resultant of those forces, that should be equal to 0. It means that if the resultant of all the forces, it means that if you add all the forces and the resultant, the sum of those forces, the magnitude of those forces is coming to 0, that means the forces are balanced. Those are both balanced forces. Clear, everyone?
Yes, sir. Yes, sir.
Forces acting on the body. Zero. The forces are the forces would be balanced forces. Okay. Balanced forces. Is this clear to all of you?
Yes, sir. Yes,
So
sir.
if I basically, if I give you the example in terms of the picture, so that should be just how many of you know this thing that weight of a body is a force?
I know.
They just know about this. What about rest of you?
Sir, no.
अच्छा चलो ठीक है, चलो ठीक है, कोई बात नहीं. Okay, everyone. So please look at the screen. This is the example of a balanced force. So how you will go? So let's analyze this thing. So as you can see, this thing, the box, heavy box is there, and it does not move at all, right? So we are force of our push. It means that we are basically pushing in the left side, right? This side, and this is a force of friction that is provided by the surface. You must have known the force of friction. Anyone is there? Is there anyone who do not know this for basically the force of friction? Who is not aware of this force of friction? Anyone? Chalo, so it means sorry, it means that everybody knows what is force of friction, frictional force, right? So force of friction is the force provided by the surface, right? So as you can see this thing, everyone, that the force of friction is there. So if the body is acting in this if the force is acting provided by us in this direction, left side, so force of friction is basically acting on the right side. So there is no movement. It means that force of friction is equal to the force of push. Clear?
Yes, sir.
Okay, now the box is already lying on the floor. It means that force of gravity will be acting, yes or no, everyone? Weight of the box,
Yes,
that
sir.
is the downwards case. So the force exerted by the ground on the box would be, that is called reaction in the upwards direction. So force of reaction is the force exerted by the surface. If all of you, everyone is sitting right now. So the force exerted by the surface on your body in the upwards direction is called reaction. Okay? Right, everyone? So
Yes.
so
Yes,
so
sir.
as you can see this thing, that there is no movement in the vertical as well of the box. It means that the forces in this case are balanced. There is no movement at all. Is this clear to all of you? Please let me know once.
Yes, sir.
Yes, sir.
Okay. So that is the force of, so basically balanced forces. Okay. So let's write down the second case. So it means that if the number of forces, balanced forces act on a body, so the body continues to remain its stationary position. Okay. Or if the body is moving with uniform velocity, so it will continue its uniform velocity. It will not accelerate at all. Clear, everyone?
Yes, sir.
Yes, sir.
The body, so just if a number of forces balanced forces. Sorry for the bad handwriting, everyone. Actually, it's a little bit humidity right now because it's rainy season in India. So it's a little bit slippery right now. Sorry for the bad handwriting. So if a body act number of balanced force acts on a stationary body, okay, the body continues to remain in its
So should we draw this?
Hi, you can draw this with a normal like rectangular block and just use the arrows.
Yes,
Okay.
sir.
At least just a normal example. You don't have to draw the proper box diagram. Okay. Just use a rectangular box like that. Let's stationary position. Next is if the body is moving with the uniform velocity. uniform motion. So the body will perform its state of uniform motion. Okay?
So when
Clear, everyone? So it's going to be uniform.
certain.
That's great. Okay. So it means that the balanced forces cannot produce a motion in stationary body, or it cannot stop a moving body. Clear? But they can only change the shape of a body. Clear, everyone?
Yes, sir.
Sure.
Yes, sir.
So we
Yes, Irshad, you were saying something.
I'm writing now.
Okay, please write it. No worries.
There are more parts of are there.
Yes, one more part is there. Chalo, let me write it. Okay. So D portion is balanced forces produce motion stationary body or stop a moving body they however change the shape of the body. Okay?
Certain.
Chalo, check.
So done.
Check. Just a minute.
Sir, done.
Check. Just a moment, everyone. चलो ठीक है. So this is the case for the balanced forces. ठीक है. So let's talk about the unbalanced forces now. ठीक है. Unbalanced forces. So unbalanced forces, as I've told you, that these are the resultant of all the force acting on a body is not zero. So those forces are called as unbalanced forces. Okay. Is not zero. Forces are unbalanced forces. Okay, unbalanced forces. And unbalanced forces can stop a moving object as well. Clear?
Yes, sir.
Yes, sir.
Sure, that's great. Okay. So unbalanced forces can stop a moving as well as the produces the motion in a we can say rest body. Okay, so next point is forces in the state. Stationary body. On day can stop a moving body. Clear, everyone?
Yes, sir.
Yes, sir.
Sure. So in this class, so far that everybody is having two chapters in their exams, right, everyone? Am I right?
Yes, sir.
Yes, sir.
Motion and forces and laws of motion. ठीक
Yes,
है? Sure. ठीक है. Sure. Moving body. So inshallah, we will complete the syllabus before your exams, everyone. Okay?
okay, sir.
So I think so. Irshad, no worries, कोई बात नहीं. Once you get it now, at least please share the syllabus management as soon as possible. ठीक है?
Okay, sir.
Or you can ask your teacher on the mobile if you are having the contact of your teacher. Because that would basically, if there is another chapter for you, so that I should have enough time so that I can prepare it for you.
Yes, sir.
Okay. So this is the you can say the unbalanced forces. I'm really sorry for the bad handwriting, everyone. So
No
as
problem.
I've told you the reason, little bit slippery is like you can say humidity is there, so I won't be able to write it properly because it's raining in Delhi right now. It's raining like since last 2 or 3 days. The rain is basically pouring very heavily. It's all everywhere water is like this completely got stuck. ठीक है. So as you can see, देखो, this is the unbalanced force. You can say diagram. अच्छा अच्छा अच्छा, ठीक है. Okay, so as you can see, everyone, that this is a car, a toy car is there. It's moving. So you are basically pushing the car in this direction, right? So if you are pushing the car in this direction, there is a force of friction as well. But the force applied by your hand is greater in the magnitude than frictional force. It means that car will go in the direction of force. Yes or no, everyone?
Yes, sir. Yes, sir.
So it's
Yes,
going
sir.
like
Yes,
this. So
sir.
it will go in the direction. Okay. And they go. These two forces are not balanced, but these two forces are balanced because the reaction exerted by the ground to the car will be equal to the force of gravity. But the
Yes.
resultant of all the force is not coming out to be zero because this force is greater. It is producing the motion. So that's why this is a category of unbalanced force. Okay?
Yes, sir.
Sir.
Clear? Chalo, that's great.
Yes, sir.
Chalo. Okay. So this is the category. So if you want to move an object, all right, it means so you should be exerting force greater than the frictional force. The applied force should be greater than the frictional force to basically produce a motion. Yes or no, everyone?
Yes, sir.
Yes, sir.
Right. So let me write the C point here. We have to produce. We have to push the body with a greater force than the opposing force of friction. Opposing force of friction to move a stationary body. Okay? My handwriting is a little bit bad because there is a less force of friction provided by the tab. You can say the tablet writing pad on which I'm writing, right? The force of friction is less here. So that's why it's a little bit slippery. But if you write it on the paper is you can say rough surface, so that will provide you a greater force of friction. So that's why your writing is a little bit more, you can say enhanced on the paper. Okay, everyone?
Yes.
Sure, that's great. Okay.
Yes, sir.
Sure. So these are the characteristics, or you can say the properties that you have to understand and learn for the unbalanced and balanced forces. Okay.
Sir.
Yes, sir.
Sure, that's great. Okay. Okay, everyone. Suppose that you are riding a bicycle, or you are basically okay. There's a moving bicycle. If there is no frictional force provided by the ground, if there is no air resistance, because when you basically, we can say when you move faster, there is a kind of air pressure at your face as well. When you
Yes.
basically travel on a bike now, you will feel that. So that is the air resistance, because air also oppose the direction of motion. Okay. So what would happen if for a like to a moving bicycle, if there is no force of friction, if there is no you can say air resistance, what will happen?
Sir, it will fly in the air.
It will.
It does not stop. It does not fail.
Ajay, so Irshad is saying it will not stop. Okay, what
Yeah,
about
it
rest
will
of you,
not
Astitva?
stop.
So it won't stop.
It won't stop by Astitva and Tejas. What about you, Rumaisa, Sara, and Sara Beg? Farhan, what's your answer? Why are you so silent in the class?
Sir, it won't stop, sir.
It won't stop. Yes. So there you go. If there is no opposing force, now obviously the bicycle is not gonna stop at all. There should, if the body is moving, so there should be a force exerting on the body to stop.
There should be
Right,
friction.
everyone?
Yes, sir.
It may be
Yes, sir.
friction, it may be air
Yes, sir.
resistance, right?
Yes, sir.
Sir,
Yeah. So hi, yes, Ishad, we're saying something.
sir, I just said yes.
Acha, change it. Okay. So
Sir, what is that? If they,
there, there were no force of friction. Air resistance. Moving bicycle. Um,
sir, if there will be no friction, so the bicycle may slip, right?
Yes, mistakes. That frictional force is the force which basically gives you the traction to the road. That's why the bikes, like you can say bike or you can say the vehicle moves easily on the road, right? Otherwise, the tire will basically rotates on its own position. Okay, sure. Okay, so everyone in this class, in this chapter, we are going to study the unbalanced forces because we will be talking about the mass and acceleration. We will be talking about the momentum. So in this case, I'm really sorry everyone for the interruption. Okay, so in this chapter, we are going to study only unbalanced forces because balanced forces will not produce any acceleration or the movement of the in the body. So basically, that will produce. So we'll be studying about the second law of motion in which the mass and acceleration is associated. So it means that we are going to study the unbalanced forces throughout the chapter. Okay, everyone?
Okay, sir.
Sure,
Yes,
that's
sir.
okay. Sure,
Yes, sir.
that's great. Okay. So this is all about the balanced and unbalanced forces. There is no numerical, only pure concept is present. So that's what is there. Is this clear to all of you? Just give me, just let
Yes,
me
sir.
know.
Yes, sir.
Yes, sir.
Okay? So if you are talking the force acting on a body, it means that in this chapter, we are discussing about the unbalanced force. Okay?
Yes.
By default, it would be unbalanced force. Chalo, theek hai. Okay, so now let's
So
understand the
there will
next
be
topic.
no balanced force numerical.
No, there is no numerical stages because this is a
Okay.
purely conceptual concept. Okay?
Okay.
So now let's understand the first law of motion. First law of motion. So Newton sir gave the three laws of motion basically. So as you know, the complete physics is, you can say, almost like 90% physics is based on the Newton's three laws, right?
Yes.
So, so he was a very great scientist and a physicist as well.
So
Basically, to
momentum is there.
momentum is there. Okay, so we are going to study the three laws given by the Sir Isaac Newton. Three laws are basically law of inertia, second law of motion, and the third law of motion, which is very famous, action ka reaction.
Yes, sir.
Okay, so action reaction law is like is a must. It's like you can say everybody has heard so far. Okay,
So this
just
is
a
a
second.
small chapter, right?
Uh, not that much small, Tejas. It's mid chapter, like average length.
Okay, sir.
Yeah.
Like action and reaction forces are the last topic.
No, no. After that, conservation of momentum is also there, Tejas.
Oh, okay, sir.
Conservation of momentum is an important. Okay. So let's understand the first law of motion. Basically, what is, so before understanding the thing, we have to understand what is inertia, because first law of motion is called law of inertia as well. To understand the law of inertia, we must understand the inertia first. So you must have, let's observe. Let's take an example. Suppose that if you are sitting in a bus, so the bus is at rest completely. Okay, there is no movement in the bus as well. Okay, so suddenly the driver accelerates the bus. What will happen?
So we go
We'll,
backwards.
You will
yes,
go
sir.
backwards,
Yes, sir.
right?
We'll go backwards.
Suppose that bus is moving already. That driver applies the brake suddenly. What will
We'll
happen?
go.
Forward.
We'll go front.
We'll
We will go forward. Okay.
Yes, sir.
Suppose that you are basically deboarding, or you are basically coming out of a running bus, or you can say moving bus. What will happen if you are basically, if you try to come out from a running bus or a moving bus, you may you may basically, you can say, lose your momentum, or you can say lose your, you can say, body posture, and you will basically on the ground, fall on the ground, right? So that the change in the motion, you can say state of the motion, is called inertia. It means that inertia is the property of a body which opposes the change of the state. It means that if you are sitting right now, the inertia would say that do not change the position, do not change the state. If you are sitting, just be seated. If you are running, just be running, right? So that is what inertia is.
If we are
So
in,
if it, yes, Tejas, you are saying something?
if we are in position, we should be in position, right?
Yes. It means that suddenly you're in rest in the bus. The bus was at rest. So suddenly the driver applies, basically accelerates the bus. So you are in the rest. So the
Yes.
bus will go in this direction, but the body will say that just be in the position in which you were. It means that, so it will produce a backward, you can say, movement, a jerk, right? So suddenly you are, and if you take an example of a moving bus, you are going like this. You are going like this in this direction. So suddenly driver applies the brake, but your body is still in the motion. So that's why you will go in the forward direction. Okay? So that's why,
Yes.
that's the reason you basically fall in the forward direction when the driver applies the brake. Okay?
Yes.
yes, sir.
So first, okay,
Yes,
so
sir.
let's
Okay, sir.
understand.
Thank you.
Okay? Chalo, that's great. Okay, so now let's understand what basically inertia is. So first of all, let me write down the thing. This is the law that I'm writing. A body at rest will remain
At rest.
at rest, and a body body will remain, body in motion will continue motion in a straight line with a uniform speed.
Sir, any assessment will be there after the class?
No,
Okay, sir. Assignment?
uh, no assignment. Because Acha, I will give you assignment of 2 questions because of the unbalanced and balanced forces.
Okay, sir.
I will check it. Unless it is compelled, unless by an
The complaint means?
introduced in the
Okay.
contact, check it, or you can say some influence, external force to change its state of rest or of uniform motion. Check everyone.
Yes, sir.
Yes, sir.
So this is the case for this is the first law of motion given by the Sir Isaac Newton, that is called law of inertia. Okay. Now let's understand what basically inertia is. So inertia is a tendency or a property of a body that resists to change the state of the body. Means that if the body is in rest, inertia would say that just be in rest. If the body is in motion, inertia would say that just be in motion. Unless the force is exerted, external force is, you can say, compelled on the body. Okay?
Yes, sir.
Yes, sir.
Any doubt so far to anybody?
No, sir.
No, sir.
No, sir.
Chalo, okay. Now let's understand the
So, is there any formula for momentum?
Tejas, we will discuss it once we will do the second law of motion for momentum.
Okay, sir. It's like change in
Yeah.
momentum by time.
Yes. Okay. So the tendency of body at rest or if moving to continue
Two.
moving in a straight line.
So, what the straight line means like? Anything?
It means that like in the unidirection, only single direction. Okay.
Okay, sir.
So B part is so if we talk about this definition, inertia is the property of a body. So inertia is a property which is possessed by each and every object in this world, because It doesn't matter whether it's living or non-living, inertia would be associated with living as well as non-living things. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Due to which it resists the change, resists the change in its state
Of motion.
of rest or of uniform
Sir,
motion.
impulse is there, right?
No, impulse is not there. This is
Okay.
impulse is in 11th class. Yeah. So uniform motion. So it means that inertia is a property that will not allow to change the state of a state of body. It means that the body remain in the same state. Okay. Okay. So next thing is that, Bachya, that more the basically first thing is that inertia is associated with mass. It means that the more the body, the heavier the body is, the more inertia will be associated. Suppose there is a car and a truck. A car can be moved by two-person, but a truck cannot be moved by two-person because the truck has a higher inertia or greater inertia because the mass of the truck is very greater than car. Obviously, yes or
The
no?
mass. Yes, sir.
Right? Okay?
Yes, sir.
So it
Yes, sir.
right? Yeah. So that's what the inertia is. Inertia is the, you can say, associated with mass. Higher the mass, or you can say greater the mass, greater will be the inertia of our body. Okay? C is
Sir, inertia cannot be smaller, right?
cannot be
Smaller than force.
smaller,
Than mass, sorry.
cannot. No, basically, it's not a comparison, Tejas. Inertia depends on mass. And it's just suppose it's a kind of thing that so these are two associated things. If there is mass, there would be inertia. If there is inertia, there would be some mass. Okay, so that's what it is. It's not a comparison. Yeah,
Okay,
I'm
sir.
just comparing that. It means that if two bodies are there, so which one will be having higher inertia and you can say greater inertia and smaller inertia. So that depends on the totally on the mass. Okay.
Okay, sir.
So inertia depends on the
Mass.
so for the D point. So it means that heavier object will have more inertia than the lighter object. Okay. There, everyone. Please do let
Yes,
me know
sir. Yeah.
if there is any doubt.
No, sir.
No, sir. Clear.
Okay. So as you can see, this thing, the cricket ball. No, Irshad, inertia is not like mass. Inertia is basically a thing. Suppose that if there is, if you can say, suppose there is a body. Okay, so you need to move that body. So the more the mass of the body will be, the more will be inertia. It means that it will resist more. It means that resistance will be offered by the heavier object will be more than the lighter object. Okay, suppose that if you want to push up, we can say a push a truck. Is it possible to push a truck by a single person? Right?
No, sir.
It means that the resistive force offered by the resistance offered by the truck is, it means that the greater than the force that you are applying, right?
Yes.
Yes or no? If you
Yes, sir.
want to
Yes,
push
sir.
up, if you want to move a car, You can easily move a car. Even a single person can move a car, because
Yes.
the resistance offered by the car is, you can say, is not that much greater in magnitude, right? So more the
Yes, sir.
mass, more will be the inertia. Okay.
Sure.
Yes, sir.
Yes, sir. Okay,
So
sir.
you can easily see this thing that suppose there is a cricket ball and there is a, you can say, a stone. A cricket ball is lighter than the stone. So more the mass means a stone will have greater inertia than the cricket ball. Right, everyone?
Yes, sir.
Yes, sir.
Chalo, that's it. Okay. So that's what it is. If you talk the example, stone, then cricket ball.
Oh,
Okay. The inertia of a body depends on the mass, as I have told you, right?
yes.
You can easily carry, you can say, carry a toy car, but you cannot easily carry a, you can say, real car on your hand, right? So
Yes,
this
sir.
is the difference. Okay.
Yes,
So I
sir.
hope it's clear to all of you. Please do let me know,
Yes,
Yes,
sir.
sir, sir. I understand.
right? So to overcome the inertia, to overcome the resistance, you should apply the force to overcome the, you can say, resistance offered by the body. External
Okay.
force should be there. Yeah.
Yes.
Yes,
Yes,
sir.
sir.
Does anybody have any doubt so far?
No,
No,
sir.
No,
sir.
sir.
Sure.
Yes, sir. Sure.
No,
Sure,
sir.
sir.
Sure. That's great. That's great. Okay. So these are the basics of the first topic, that is the law of inertia. And balanced forces and balanced forces are kind of a very small topic. But if we talk about the, what I was saying, if we talk about the law of
Momentum.
inertia, so this is the first topic. Okay.
Yes, sir.
Is this clear to all of you? Please do let me know.
Sir, what is the
Yes, sir.
formula of momentum?
They just we will discuss in the next class, because right now momentum is, you will not understand unless I will explain it. And you can say like this class is about to end, so we'll discuss it in the next class. Okay.
Okay.
Yes, we will start the momentum in the next class, because inertia is, there is no numerical in this topic as well. So once the theory will be completed, so we'll start the next topic, that is this momentum, and then we'll start the second topic, second law of
Okay,
motion.
sir.
Okay. So I hope it's clear to all of you. Please let me know, everyone.
Yes, sir.
Yes, sir.
Sure. Okay. Okay. So that's all for this class, everyone. Thanks so much for joining the class and giving me your time. Till then, next class. Take care. Bye bye. Allah Hafiz. Good night.
Yes, sir. Thank you
Thank
so
you,
much.
sir. Bye, sir. Take care.
Welcome. Bye. Same to you.